Hello, hello. Okay, there we go. Got good sound out of this microphone. All right, so thank you all for having me. I'm the News 8 morning meteorologist. So you might see me on TV on CBS, on the CBS affiliate. So if you see the Bills on Sunday, that's the channel that we're on, News 8, CBS. So yes, I'm a meteorologist. I'm not just a face on TV. I actually do the science as well, and that's what we're going to focus on. We're going to focus on the science. And this is kind of a new presentation for me, so this will be fun. And usually I talk to third graders, so this is, I had to change my presentation a little bit. Not too much, but so this is the content. This is kind of what I'm going to go over. And how's the sound? You guys can hear me pretty good? Good?
Very good.
So we'll go over New York State geography, we'll go over climatology, we'll talk about using the National Weather Service, which is the government entity that also forecasts the weather for New York State. We'll talk about getting the forecast, which is obviously very important. We'll talk about tools to have, summer forecasting, cloud identification, safety, and then if we have time, we can do a little winter forecasting. We're going into summer, right? So we're thinking about summer, so we can skip winter forecasting if we have time. We'll see. And then we can do Q&A at the end. So if you have a really burning question, I can get to that, but otherwise we can save that to the end. So New York State, there it is, our beautiful state. Lowlands along Lake Ontario, that's where we are now. You have increasing elevation as you get into the Finger Lakes. You got the 46 peaks in the Adirondacks. You got Mount Marcy, that's the highest peak, just over a mile up in elevation. You got the Southern Tier, Allegheny Plateau, and we get all different kinds of weather. Severe weather, lake breeze, thunderstorms, downslope heating. That's if you get a southwest wind at the exact right angle, we get spike in temperatures in Rochester, things like that. Then of course, winter, lake effect snow, nor'easters, things like that. So the climatology is interesting. The graph you see is just Rochester. So the lines are temperatures, and the red line is high temperature, the blue line is low temperature, warmest in July, coldest in January, we know that. I think what's interesting is the precipitation, the rain/snow is actually relatively equal across the entire year. And our lowest rainfall, quote unquote, is actually February. It's the liquid equivalent of the snow. It's not just inches of snow. The highest rainfall you see is in July. And a couple of fun records, 108 in Troy, back in 1926, Troy, New York. The record low was -52 in Old Forge. You got record rain, record snow. I don't know how the heck they got 467 inches in Montague, but they can regularly get 200 to 300, so I guess 467 is possible. Rochester, there's our averages 60s to 80s in the summer. In the wintertime, it's upper teens to low 30s. And then there's some Rochester records. You got 102 back in 1936. A lot of people ask me, what's the warmest Rochester has ever gotten? Well, the temperature, 102. There's your answer. -22 is the coldest we've ever gotten as well. And then we get about 100 inches of snow. It's kind of an easy number to remember, 90 to 100. All right, so National Weather Service, you have several offices across the state, and we work with the National Weather Service office in Buffalo. So you can see the orange there, Monroe County. So I regularly am in conversation with the National Weather Service about specific forecasts, especially when it comes to wintertime and snow and things like that. How much snow they think we're going to get, how much snow do I think we're going to get, and then we kind of work it out. That happens very often. It's very common for public-private, conversations, like in any business, right? So if you're hiking in the Southern Tier and you're trying to get your severe thunderstorm warnings, we'll talk about that in a little bit, but you probably would get them maybe from the Binghamton office, or if you're in the Adirondacks and you get severe thunderstorm warnings, that might be from either the Albany or the Burlington National Weather Service. So we'll talk about getting those updates regularly. It's important, especially when you're out on the trail. And that's what we'll go over now. So this is kind of the meat and potatoes here that I think is really important. Okay, so we all, I'm going to talk a lot about cell phones, using your cell phone as your tool to forecast. There's, of course, when you have a signal and when you don't have a signal. Because I'm assuming that a lot of us, when we're on the trail, we're going to be dealing with both, right? So, assuming that you do have a signal and you do have Wi-Fi, we want to make sure that we know what the forecast is before we walk out of the house. Before we go camping, we're going on a 4-day trip, you got to know what the forecast is every single day. And you do that with an app. The generic iPhone app is not very good. We're talking weather, right? The weather app is not very good. But most other apps do a generally pretty good job. There's hundreds of weather apps on your phone. And I hate to just say one app is the best. What I usually suggest is find the one that you like, the one that has a good user interface, and it has a couple of things. One, it's going to tell you when there's lightning in the area. So you need to make sure that there's lightning data on the app. It should say, oh, there's lightning in the area, seek shelter, something like that. That would mean you need to have your location set on. And it's probably worth paying for it. I hate paying for apps. I very rarely pay for apps. There's only a few that I pay for. But your weather app is, if you're going to be out on a trail, your weather app is probably going to be worth paying for. So when people really do, they press me, what app do you use? Well, the News 8 app to watch a forecast. Like I like to watch a meteorologist talk about the weather. And then I have Radar Scope is what it's called. And it's just radar, and it does a really nice job at showing what radar looks like and how clean it is. And then I have a direct link to the National Weather Service page for Rochester. So I can go right to the National Weather Service page if I'm in a pinch and I need to know when the weather is there. Other options, Strike, Weather Lab, My Radar is a really good one. And again, there's a free version with ads, right? But if you're out on the trail, you don't want to see ads. So I suggest paying the $5 or the $10 or whatever it is for the app. Fork over the cash. I know you don't like to, but do it for the weather apps, right? Weather Underground is a big one as well. Find the one that you like. Find the one that will notify you if there are storms coming, right? If there's a severe thunderstorm warning in your area, you need to be notified. Make sure that is turned on. So that's the key. That's really the big one that I kind of want to highlight. And that's, of course, assuming that you have Wi-Fi. We'll go over kind of what you can do if you don't. All right, really quick on summer forecasting. There's Rochester, New York State, typical storm system. You get a low pressure that's working its way towards us. In this scenario, the warm front would be pushing overhead. You can get rain along the warm front, but look north of the warm front. You see cloudy and an east wind. East wind usually means something is coming, something is on the way. So that's something that you can use when you're out and about if you don't have any service or anything like that. East wind, probably some rain coming, but likely kind of stratiform area-wide rain. You get a south wind, you're probably somewhere in that warm bubble where you could have some rain showers around and you could have storms coming as well, maybe a cold front on the way. You have a west wind, well, the storm may have already passed. Maybe you got the downpour cleared through and it's getting colder. Well, you're in the cold sector now. That west wind probably means the storm is out and the skies are going to start to clear up. You get a north wind and it's going to be chillier, but ideally you don't have any storms coming. And this is really kind of summertime for summertime forecasting. So those are kind of some rules of thumb that you can remember. All right, this is the fun stuff. Let's go over some clouds. We'll talk about cloud coverage. So this is how we're going to do this. I'm going to try to give you ways to remember the clouds. Kind of funny little quirks, things to remember the clouds. So the two we want to do is cumulus. Think of cauliflower, right? Kind of looks like cauliflower. And stratus, which is straight or sheet in Latin. And then, so remember those two, and then you've got nimbus, which is, that just means rain. But really, cumulus and stratus are the two that we want to remember. And we'll go through each height. High, middle, and low. So we'll do cumulus and stratus, and we'll do it at each height, right? So we'll start with high clouds. Why so cirrus? That's how I remember it. I know, kind of goofy, but it's a good way to remember it. Why so cirrus? Because they're not a big deal. They're no threat. They're just high ice crystals. You've got cirrocumulus, you can see on the left, kind of those puffy cauliflowers, and cirrostratus. That's when you get those cool halos. Stratus, the sheet, the layer, right? So you'll notice a trend. Middle clouds, alto. Alto saxophone, right? Alto saxophone's kind of in the middle, right? It's one of the middle saxophones. So you think alto, middle, alto saxophone, middle clouds. Obviously this is fake. If I don't, hopefully you can figure that one out. So let's go over the alto cumulus and alto stratus, right? So these look like the cirrus clouds, but they're a little bit lower. They're alto, they're in the middle. So there you go, you've got alto, cumulus, alto, stratus. Now when you start to see these, you're like, okay, maybe there's a storm coming because the clouds are getting lower. That's a really good sign that there's probably rain on the way. Clouds are lowering, they're lowering, they're lowering. Especially when you see that. And alto stratus, you know it's alto stratus because that's always what it looks like. It's a sheet and you can just kind of barely make out the sun. Very common with alto stratus. Now we'll go down to the low clouds, right? Now we've got cumulus, which will get some vertical development. That's not going to be producing any rain. And then you've got stratus. Stratus can produce rain. If it is producing rain, that's the nimbostratus. So that's at the low level, right? So let's go back, let's review. We've got our high clouds, cirrostratus, cirrocumulus. Middle, alto, alto, stratus, alto, cumulus. And then we've got our low clouds, stratus, stratocumulus. And then, of course, the cumulonimbus. So oftentimes if you have a front coming, you'll see the clouds lowering and lowering and lowering. And that's usually with fronts. Let's talk about thunderstorms now. And this is, let's say you're going on the trail and you get that like 60 to 85 afternoon thunderstorms. You're like, what the hell am I going to do with that, right? I'm going on a hike and I'm not going to have service and I'm just trying to figure out if there's going to be storms. And you got to be prepared for storms, so you just hope you get lucky, right? Well, what we're going to do is we're going to look at the cumulus clouds because we're going to start to see cumulus clouds forming. And we're going to look, let's assume it's to our west, right? Because generally things move west to east. So you look west and you see the cumulus clouds starting to form. You get rising motion because you've got instability. So I think I have a laser pointer. That would really help me here. There we go. All right. So what you're looking for is you're looking on the edge of these clouds, like on the outside. And as the vertical development of the cloud builds, it's going to be really defined on the outside, and you're going to see it billow up and billow up because the instability, the positive buoyancy is just going to grow and grow and grow and grow. And you're not necessarily getting rain yet out of this kind of cumulus, this early stage. Once it starts to get mature stages and the updraft is too strong, and the hydrometeors, the ice crystals and the raindrops within the clouds start bumping into each other, and they get heavy enough, they'll fall. They start falling out, and voila, you've got rain. So as that storm gets bigger and bigger, we're talking, look at how high this is. 15, 20, 30,000 feet. This is where planes fly. Sometimes they get all the way up to 50,000 feet. These are the storms that can produce hail, can produce 60-mile-per-hour winds, can produce tornadoes, things like that. That is, of course, the developing, the mature stage. It's kind of in between the mature stage and the dissipating stage when you get the real bad stuff. But what we want to look for, let's get the advance here. Here we go. I like this. This is nice. See that? See how it's kind of billowing? And a lot of times people don't stare at these clouds like I do. Just stare at it, look at it, and if you focus on one point, it's really cool actually. Sometimes you can see the actual cloud pushing upward. And that's a cloud that's developing, and if it's rapidly happening, you're like, oh boy, this is probably going to be producing some rain or some storms. Now, I'm assuming if you're in the woods, you're probably only going to see this part, and you're not going to see any of this, because there's trees and things in the way. So that's what you look for, right? If you have Wi-Fi, ideally, your phone will tell you if there's lightning, and that's when you can take cover, which we'll also talk about momentarily. Another thing you can look for is anvils. If it's got kind of an overshooting top, like this, that means it's a very strong storm. That means it's a very tall storm as well, and it's probably going to last a long time, and it's probably going to produce very heavy rain, hail, things like that. So there's certain things that you can see with these storms as they develop. Okay, let's talk about safety when in a storm here. Starting with the first one, someone knows where you are, right? That's a good one before you leave. Finding a structure, finding a car. Getting in a car is very safe. And that's kind of like where I would just basically put my foot down. If you're near a car and there's a storm, get in a car. If there's no structure or anything like that, right? It's not the tires, it's the Faraday effect. Basically, if the car gets struck by lightning, the outer shell, the aluminum or metal shell, will just absorb the lightning. There might be some impact to you, but a car is like bottom by far the safest place to be. If you're in a tent and there's a severe thunderstorm warning, get out of your tent and get in the car. Wait till the storm passes. So that's the big one. You could probably just move on from there. But if you are out, you find yourself hiking, maybe for example, and you get that severe thunderstorm warning, or you see the storm coming, you hear the thunder, right? That's a big one. You hear the thunder. These are some things that you have to do. Finding a low area like a valley, avoiding water, avoiding tall objects, no open fields, right? Spread out if you're in a larger group. Don't be holding your metal water bottle while the storm's moving through, right? That's obvious. And then that last one, of course, as I already mentioned, if you're in a tent, you really just want to get into your car. It's 6:50. We got time for winter forecasting. Why not? Winter forecasting. That's really why I live in Rochester, right? Love winter. Winter precip type is fun. So this scenario over here on this side is what we deal with in the summertime, or most of the time. You have warm air at the surface, and out of the cloud it's cold, but it just goes into warm air and you get rain. But as the temperature in the column of air above us changes, that is when you start to get different types of precipitation. So let's say this is a cold front, right? And this is 32 degrees. Cold fronts can drive into warm air, and so you have a layer that's above 32 degrees above your head. But then at the surface, it's actually colder. So what can happen is you can have rain, snow fall out of the cloud, melt, turn into rain, and then freeze on the ground because there's a very thin layer of below 32 degree temperatures. If the layer is thicker, the rain drop will have time to actually completely refreeze and you'll get sleet. If it's completely cold, then you have snow. So what we can do as meteorologists is we can launch weather balloons and see what the temperature of the atmosphere is, not only at the surface, but 1 mile up, 2 miles up, 3 miles up, 4 miles up. And we'll say, okay, it's 28 degrees at the surface, it's probably gonna snow. And then we launch our weather balloon, and then a mile up, it's 36. We're like, wait, it's 28 degrees here, it's 36 degrees up there. What's going on here? Well, maybe this scenario is happening right here. So that's when we would forecast freezing rain, for example. Or it's 28 here, and then it's 30 above us, and then it's 36, so we know the layer's actually a little bit deeper, so we can call for sleet. And then, of course, we use computer models to help us out with that. So that's winter forecasting. Lake effect snow is fun. It's also torturous. Trying to figure out where the snow is going to fall. It's one of the most difficult things to forecast for. You really can get it any time of year, but it's all about instability. It's all about having warm air and warm water at the surface, and then very, very cold air aloft. So you have warmth at the surface, cold air aloft. That difference in temperature forces air upward. So you have cold air from Canada coming over warm Lake Ontario. So let's say it's October, November, when the lake temperature is 60 degrees, and the air temperature is 30 or 20. That immense change in delta, if we want to get fancy, in temperature, forces warm air upward, it condenses into clouds, and then it moves inland because of the wind, and then that creates snow. And there's a bunch of different patterns and things like that that we forecast for in order to get lake effect snow, and that's how you get so much snow in Montague and Tug Hill Plateau and things like that. There's an average annual snowfall from the National Weather Service in Buffalo. You can see, obviously there's the bullseye up there in, Jefferson County and Lewis County up there. Oswego County as well. It has that kind of 150 to 250 range. There's us in our humble 75 to 100. And then you see, of course, east of Lake Erie there, they've got the 150 to 200 range again because of the lakes. And the prevailing west wind, right? That's what you need, a prevailing west wind. All right, there's the presentation. Thank you guys for listening to me, and I will open up to any questions that you have. Okay, go ahead.
Do you see any impacts of the tree cuts to the National Weather Service and NOAA impacting your ability to forecast as well as the services provided to people like us?
Yes, I do. I think so. I think the budget cuts For what it's worth, when it was initially happening, we lost a lot of veteran forecasters in a lot of offices, which was unfortunate. A lot of them were kind of like within years of retirement, so it kind of just accelerated the retirement, which I know happened in a lot of other places as well. But a lot of the hurricane hunters and for severe weather were actually rehired several weeks later because it was definitely a big oopsie when we lost them. But it's definitely pinched. I have seen higher error levels in watches and warnings. So I've seen some storms that weren't warned that probably should have been warned, and then some warnings that have lasted a little bit too long. So I've just noticed like a little bit of like a lack of urgency, I think. And I think this is going to be a real problem when hurricane season shows up. I'm a little bit concerned about that. When we see a Cat 5 hurricane headed toward Texas or Florida or areas that may have divested and that kind of stuff, that's when things can get a little bit scary. But from a day-to-day standpoint, you can't notice it. It's when the storms hit that could be really scary. So.
Wait a minute. We got
a mic to pass.
First of all, thanks for coming here. We appreciate it. How do you find that the wildfire smoke from out west and up north affects your forecasting?
Yeah.
It's been prevalent over the past few years, and how has it changed for you?
Sure. I never used to have to forecast for wildfire smoke, so that's definitely been different. But there are some really good computer models that do forecast for those particles that have come out recently that we've been able to use, so that helps as well. It pulls down temperatures. My high temperature has been way off sometimes because it absorbs radiation, right? It absorbs radiation from the sun, so that's going to pull high temperatures down. Ozone levels at the surface, or just the air quality is AQI, right? Never learned about AQI in college, and so that was new as well. For what it's worth, we haven't seen too much smoke so far this year, and a lot of Canada has burned already, which is also unfortunate, but nothing too bad yet. Did you have a question?
Could you discuss snow bands in a little more detail? I often hear in a weather forecast of the term persistent snow bands.
Sure.
And I'm never quite sure what that means.
Yeah, snow bands. Yeah, sure. What if there's a way to draw? That'd be really great. Snow bands. I don't think I'll be able to draw, but so I'm trying to think about how I can explain this here. When you get a prevailing west wind off of Lake Ontario, let's use Lake Ontario for example, right? And you have a northwest flow. That's going to generally spit out snowfall over Wayne County, for example. And the reason why we call it a band is because it's like a long strip, usually, of snow that you see coming into an area. And the reason why it's often a long strip and not like kind of a broad area is because the wind needs to be able to pick up on moisture off of Lake Ontario. So it needs to be able to pick up a significant amount. A fetch, for example. That's why when you have a west wind, you don't really get lake effect snow off of Seneca Lake, for example, or Keuka Lake. You know, those lakes don't produce lake effect snow because they're not big enough. You need air moving over a very continuous direction over a long period of time, and that will help produce the lake effect snow that if you want lake effect snow. And so what happens is it produces bands. So when you look on radar, oftentimes it will show lake effect snow bands. Like a strip, I guess, is kind of why we use that word band. So.
Thanks.
Any other questions? Yeah.
Real large hail.
Yeah.
Although last summer
Yeah. So last summer we got the most tornadoes ever in New York State. We had 29, I think. So it was a very busy, severe weather season. As far as hail is an interesting one. I definitely have seen more hail events as well around New York State. It might just because people are more aware of it. We see more people that understand it or see it or report it, that we get more of it. But basically it's when you get those clouds that are billowing up, and we show kind of the mature stage of that cloud. and the vertical velocity and the positive buoyancy of all the hydrometeors, so the ice and the water molecules are all bumping into each other. And as long as the vertical motion is so strong that they keep bumping into each other over and over and over and over and over again. And if that vertical motion keeps going, they're going to get bigger and bigger and bigger. And then when they get so heavy, gravity wins eventually, then they fall out of the cloud. So as long as you have enough energy to keep that thing up there, it'll just sit in the cloud and grow and grow and grow until eventually it falls out of the cloud. So
can you explain can you explain what a weather balloon is, and do you literally launch those on a frequent basis?
yeah, what a weather balloon is. So a weather balloon is, they used to use helium. I think they switched from helium. They use another gas because helium's expensive now. But it's a balloon. It's about this big. It's 6 foot wide. And they launch it in Buffalo. They launch it at just about every National Weather Service across the country, and a lot of other places across the world launch weather balloons. And we put this thing called a radiosonde, or Raymond-sonde on the bottom, and it's a sensor. And so they fill the balloon up, and it's, you know, a little device. And then they just launch it, and then it goes, and as it's going in the air, it's taking the temperature, the dew point, the wind speed, the humidity, the pressure is a big one, and then as it's floating in the air, it's going down to your computer, right? You're getting the data instantly, and then it goes up, it goes up, it goes up, and eventually pops somewhere once it can't go high enough, and then the thing comes down, and there's a little message on it if you receive this return to National Weather Service, basically. And then we can use that data. It would be great if we launched one in Rochester, but we don't have one. That's another thing with the budget cuts. They might get rid of the launching the weather balloons, which would make me very sad because it's good data. But the data collection that we do, how our models work, it's all about data input. And most of our data is from satellites. Satellites just constantly spinning the Earth. We get terabytes and terabytes of data each second of constant feeding weather data. A lot of people ask me that, like, what's a weather model? What are these models that we look at? And that's really what it is. We're constantly collecting data 24 hours a day, 7 days a week, every day of the year, and it's feeding into these huge supercomputers that output weather data, because there's like 7 to 10 equations that we use in meteorology, and all of this data feeds into these equations that output a forecast model. So we have some hyper-local models, and when I say hyper-local, I mean it's just like New York and the Northeast, and we can use those for hourly forecasting, for example, like day to day. If there's internet connection, I could actually kind of, how much time do we have? Is there like a cutoff time here? Is it? Quarter after, okay. Let's see if I can use internet here. Jerry, is it okay if I use internet on this? You want me to use Firefox, or which one do you want me to use? This one work? Okay, let's do this. God, actually, you know what? Tropical tidbits. Tropical. I know this site is made for. Trying to think of, hurricanes and things like that. Not connected, busted. I don't think we have Wi-Fi. Oh man. Tech support. Oh, it's available. Here we go. Arrow over. RMSC guest. You gonna make me put a password in? This is serious tech work right now. This is too much. If you want to do that, could you punch it in for me? So what I'm going to show you is I'm going to show you a computer model. And there's multiple different models. There's short-range models that go out like 12 to 18 hours, and they're great for forecasting for thunderstorms. So if you really want to go crazy on your weather forecasting, and you're like going on a hike, and you see that PM thunderstorms thing, I'll show you how to kind of really help time out that. What meteorologists look at. I'll give you the inside information that we don't tell anybody. And then there's the global models, right? So you have these hyperlocal models that use a ton of data and that give you really hyperlocal, like smaller grid space forecasts. And then you have the global ones that go out 10 to 15 days that show you kind of like generally what's going to happen. Oh, it's working. Okay, this is going to be quick. This is going to take 2 minutes. Okay, watch this. TropicalTidbits.com. Save that website if you want to remember. Again, this is free. This is all public data. This is paid for our taxpayer money. All right. So, mesoscale means smaller scale. HRRR, high resolution rapid refresh, is what that stands for. So you choose the model time, get rid of the pop-ups, and then, so what we're going to look at is we're going to look at, like, when you watch a meteorologist on TV, they'll show you like a future cast. This is kind of like that, except this is updated instantly all the time. Where's my local view? This is right. Northeast, there it is. Okay, northeast. Do we all see Rochester? Right there, right? Okay, so this is, I'm expecting there to be storms tomorrow afternoon. Watch. Now, I know it's tough to see the time. I'm gonna point it out here. So it's Zulu time. If anybody knows what that is, Greenwich Mean Time is right here. So you have to subtract 4 hours. You gotta do the math in your head. That's 8 a.m. 9, 10, 11, 12, 1, 2, 3, 4. Oh, there we go, look at that. See that? See the grade popping up? So if you really want to be a weather nerd, and you have a hike tomorrow, and you're on your computer this evening, and you say, you know what, I'm gonna pull up Tropical Tidbits. Because I saw the meteorologists on TV say afternoon storms, but I don't really know what that means. So you're going to pull up Tropical Tidbits, and you're going to look and say, oh, I'm going to be in Fillmore Glen State Park in the afternoon, and by 3 o'clock there's going to be pop-up storms. See that? Isn't that nice, right? You use a site like this, and this HRRR is updated every single day, every single hour they update it. But every 6 hours they go out further, so stuff like this you can kind of look at. I think this should be able to go out even further. Now there's going to be a big storm complex that pops up. There it is. Look at this monster. In Michigan. That's a warm front right there. And it should be here early Friday. All right, so I do our math. 10 minus 4 is 6, so that's 6 a.m. Friday morning. That's going to be a fun morning. And then the storm system kind of dies out there. So that's the high resolution model. This is great for those afternoon thunderstorms. And then, now you can do the global models. So this is the American global model. I'm going to zoom out because it looks better when you're looking at it. This will be the last thing we do. Okay. Continental United States. Now this goes out and goes and goes and goes. This is like when your nephew says, hey, I have a wedding in 2 weeks. Is it going to rain? All right, let me look at the global models. So I've really skipped ahead already. I've skipped over the weekend. You see the time here. We're already into Monday next week. Looks like a good week. Now, once you get out past 7 days, I call it La La Land. You really have no idea what the hell's going to happen. So the 10-day forecast that Channel 10 gives out is bogus. Stick with 8 days. Stick with me. So look at how far this goes out. This is going to bring us. It's silly for me to show you this because it's like, it's looking at fairy dust here. This is to the end of the month, you know, so it goes all the way to Wednesday. So this is dangerous because some people look at this in the wintertime and the model does crazy things when it goes out 14 days because it's like the butterfly effect, right? The butterfly flaps its wings in California and you get a snowstorm in New York State. Well, it shows crazy things when you go this far out. It shows huge hurricanes, shows massive snowstorms. But anyway, okay, I think that probably does it. Thank you guys so much for having me. I really appreciate it. If you ever had any questions, send me an email, jgilbert@wrctv.com. Thank you.